All right, we're going to talk about chemical equilibrium and how you can force the reaction to either go forwards or backwards, called Le Chatelier's principle. First, let's talk about equilibrium and equilibrium calculations. When you're setting up a equilibrium expression, you always put your products over your reactants. Okay? So, and your products are always listed second, and your reactants are always listed first. It doesn't matter which direction it is going in. The reaction to go either way based on what you do with it. When you're doing it, you set it up equal to where you have the each individual concentrations of your products and reactants raised to their coefficients. So the little letters here are your generic coefficients, and the big letters are your compounds that are involved. So you can see that you've got your products over your reactants, and they are raised to their coefficients. Okay? And when you're doing these, pure substances are not included, and that means liquids and solids. Not aqueous solutions, but an actual liquid itself is not included, and solids are not included either. So we want to do some practice here. We've got the first equation, everything is a gas. So what you're going to do is you're going to put your products over your reactants, which is your ammonia squared, because there's a 2 right here, and over your different reactants that are going to be multiplied together. And you've got nitrogen, there's nothing there, so it's an understood 1, and then your hydrogen is the 3. So that's where these numbers come from, is from the coefficient. And then it's understood 1 if there's nothing there. Okay, there we go. You see that you have sodium bicarbonate breaking down into sodium carbonate and carbon dioxide and water vapor. Because this is a solid, it's not going to be involved, and that's a solid, so that's not going to be involved. So the only thing that's involved in your equilibrium expression is your carbon dioxide and your water, and they both have an understood 1, so they're not going to be raised to any power. So your expression for this one will look like this, where you have your K equals your CO2 times your H2O. Well, of course, you know we're going to plug some numbers into these problems. So, if going back to the first example of your nitrogen and your hydrogen, you have the hydrogen is a 0.15, the nitrogen is 0.25, and your ammonia is 0.1. So when you're calculating the K, you're going to write out your expression, which we did before, and then you just plug in your numbers, substitute them in, and you get 11.85 is your total there. Now K's have no units. So this is your one time that you can, or one of the rare times this semester that you'll be able to just give me a number without any unit behind it. Alright, let's talk about Le Chatelier's principle. His principle says that if you apply a stress to a system in dynamic equilibrium, which is what the stuff we were just talking about, the calculations, the system will change to relieve the stress. And so when what we're talking about here is if you are increasing your concentration or temperature or decreasing whatever, which direction is the reaction going to go? So when you have the temperature and concentration, they both, if you increase the concentration of something, it'll shift to the opposite side. Meaning if you add a reactant, add more reactants, you're going to make more products. If you add more products, it's going to make more reactants. We're going to do some practice problems in a minute. So that should also go so that if you're decreasing, then it's going to shift to whatever side you are changing something on. So the same side of the reaction. Pressure is a little different. If you increase your pressure, it's going to go to the least number of moles of gas. And if you decrease it, then it's going to go to the greater number. So it goes to the most gas moles. And then when you have solids, liquids, or inert gases, your inert gases, meaning your noble gases, nothing happens. So nothing. When you're talking about solids, liquids, gases, or noble gases, I should say. So let's do an example. If this is your equation, you've got solid carbon reacting with water vapor and heat to cause a reaction to happen. What's going to happen with carbon dioxide, or forming carbon monoxide and hydrogen? So if we lower the temperature, that means you are taking away temperature. So what's going to happen here is the reaction is going to shift to replace what is being taken away. So it's going to the left, which is your reactant side. Okay. If we increase pressure, so we're increasing pressure, that means we're going to the side with the least number of gas moles. You see on the reactant side, let's change the color here, you have one gas molecule here. On the product side, you have 1 plus 1 that makes 2. So therefore, it's going to shift to the left, which is your reactants, because you have 2 here and only 1 on this side. We only look at gas when we're talking about pressure, or gas molecules, or moles, however you want to look at it. If we remove hydrogen, meaning we're taking away hydrogen gas from the system, what's going to happen is the reaction has to replace that hydrogen. So it's going to shift to the right, which is your product side. So the reaction will occur in the forward direction, replacing what hydrogen you have taken away. Because going back to your equilibrium constants, those values are the same. So in order to keep a ratio equal to that one value, then you have to adjust your numerator and denominator. And that's what's happening in all of this. If we add, so if we're increasing our hydrogen, then what's going to happen is it's got to break down, combine with your carbon dioxide to make more water and carbon solid. So it's going to shift to your to the left, which is your reactant side. Okay? In order to maintain that ratio, that whole number ratio, or whatever number ratio that you have. And then if we add neon, what's neon? Neon is a noble gas. What color have I not used? There we go. It's a noble gas, so nothing happens. We will actually be doing a lab where you will do something similar, and you'll be able to visually see what's being produced, whether a reactant or a product based on color change, and you'll go through and make various changes to what's going on. So you'll be able to see this in class whenever that's scheduled for. We'll talk to you later. Bye.